Hi everyone. I just wanted to give you a chance to check your work on this test, this practice test, so you'll be ready for your test tomorrow. Alright, so I'm just going to go through these problems. Number one says use a protractor and ruler to classify the triangle by its angles and sides. Alright, what we're going to look at right here, that's the biggest angle, and it looks like it's a little less than 90 degrees. So we're talking acute angle with the biggest angle here, and this is acute, this is acute. So it is an acute triangle, and that's classifying by its angles. And then I'm looking at the sides, that's a short angle. This is a little, this is bigger, and this is bigger yet. None of the three sides, so I'm going to avoid getting the ruler out and just go by sight here that this is acute, and since all three sides are different, scalene. If this had been an obtuse angle, I'd have put an obtuse here. If it had been a right angle, I'd have put right here. But the biggest angle is acute, so it's an acute scalene. No two sides are congruent, so it's not going to be isosceles, or if all three are equilateral. Number two goes right to equilateral. You need to pick two sides, any two sides, and just set them equal to each other if you're needing to find x. 10x minus 6 equals 7x plus 3. I'm just picking these two. I'm going to subtract 7x from both sides. So I'm solving for x because x is one of the things I was asked to find here. 3x minus 6 equals 3. When I add 3 to both sides, I got 3x equals 9. So x is 3. And when I plug it in, 10 times 3 is 30. 30 minus 6 is 24. So AB, 3 times 7 is 21, plus 3 is 24, 8 times 3 is 24. AB is equal to BC, which equals AC, which equals 24 units. Now number 3, it says find the measures of the sides of the triangle if the vertices of triangle EFG are -3, 3, 1, -1, and -3, 5. Then classify the triangle by its sides. All right. Didn't think I had, but I wanted to do this on a piece of graph paper. And E is at -3, 2, 3, positive 3. Here's E. F is, let me go a little higher here, at 1, -1. So here's E. Here's F. And G is at -3, 1, 2, 3, 4, 5. Here is G. All right, so I'll connect the sides. EG is 1, 2, 3, 4, 5, 6, 7, 8. That's 8 units long. So now, what I was doing, some of you we would kind of look at, if I made kind of a right triangle out of this side would be 1, 2, 3, 4. This side would be 2. And then 2 squared plus 4 squared equals the length of this squared, using the Pythagorean theorem. And that's the square root of 4 and 16 square root of 20. So the length of this side is the square root of 20. And if you look here, 2 and 4 again, this is also the square root of 20. Classifying by its sides, the sides are congruent. It is, I'll put it down here, isosceles.
For an interruption, pay Maya voting to the main office, please.
All right. Number 4, measure of angle 1 in this drawing. First thing I think you really need to do is take 180 minus 110 and say that that angle right there is 70 degrees. These two sides are congruent. That means these two angles are congruent in an isosceles triangle. So angle 1 is also 70 degrees. This is 70, this is 70. 70 plus 70 is 140. And 180 minus 140 is 40. And I'm doing that just to get this angle right here. That is 40 degrees right there. 40 plus 140, and I could have used the exterior angle theorem. 70 plus 70 is 140, so this angle right here is 140 degrees. That's angle 2. This is 40. It is supplement to this. It's congruent to the vertical angle there. This is 90. 40 and 90 make 130 degrees. I'm going after this third angle, angle 3 here. 130 degrees. 180 minus 130 is 50 degrees. Number 7. Okay, here's what we're looking at. F corresponds to A. Oops. A over here. F and A need to be the first in each triangle. This has got two loops, so I'm going to put G here and C here. And then left with D and B. As long as the F and A are in the same position, the G and C are in the same relative position, and the D and B are in the same relative position, we're good. Okay. This bottom one here on number 8, I'm going to kind of do the same thing that I did over here, is finding the sides to see that congruence has been preserved. I want to verify that the sides are the same length. They said the angles are, so they already told us that. 1, 2, 3, 4 over 1. So that's 4 squared plus 1 squared. That's 16 and 1 is 17. So the square root of 17 is what BC is, square root of 17. And then B prime, C prime, 1, 2, 3. Did I miscount? 1, 2, 3. That's 3, not 1. So that's 10. So that's square root of 10. This also has 1 or 3 and 1, so that is also the square root of 10. AB, I go up 1, 2 over 1, 2, 3, 4, 5. 2 squared plus 5 squared, that's 4 and 25 is 29. So this side is square root of 29. 1, 2, 1, 2, 3, 4, 5. This is the square root of 29. 1 unit there, 1, 2, 3, 4 units there. 1 and 4. 1 squared plus 4 squared, that's 1 plus 16 is 17. That one's the square root of 17. 1, 1, 2, 3, 4, that's also square root of 17. Okay, all corresponding angles are congruent. All angles, they already said. All corresponding sides are congruent. So this flip over the x-axis, the reflection over the x-axis, keeps it congruent. Doesn't change the fact that they're still the same size. All right, number 9. ABCD is a quadrilateral with AB congruent to CD and AB parallel to CD. Name the postulate that could be used to prove that triangle BAC is congruent to triangle DCA. Choose from SSS, SAS, ASA, and AAS. All right, so I've already got 2 sides congruent, one from each triangle, AB and DC. I also know that when lines are parallel, the alternate interior angles are congruent. So these 2 angles are congruent. And then the third thing that I think we can use is AC has a shared side. So AC is in both triangles, so that side is congruent. And when I see the marking, sides, angles, these angles, and this shared side, side, angle, side. Okay, so when you show me this tomorrow, I want you to explain what you have. So if I'm explaining it, I got DC congruent to AB, BA. Okay, that because that was given. I've got angle BAC congruent to angle DCA. That's because of the parallel lines, alternate interior angles. And I have AC is congruent to itself by the reflexive property. So that's the side, the angle, and the side. Number 10, triangle KLM. KLM, the big triangle, is an isosceles triangle, and angle 1 is congruent to angle 2. Angle 1 here is congruent to angle 2. Name the theorem that could be used to determine LKP. This triangle here on the left is congruent to LMN, this triangle here on the right. Then name the postulate that could be used to prove that those two triangles are congruent. Okay. So, okay, I understand. The theorem, the fact that this is isosceles triangles, that means these two sides are congruent. LK is congruent to LM. Now, in addition to that, angle K and angle M are congruent because angles that are opposite congruent sides are congruent. So when I look at these two smaller triangles here, I see we have two angles here that are congruent. That was my warning. I need to finish this problem. We have two angles here that are congruent, and we have these two sides that are congruent. This side is not between the two angles. This side is not between the two angles. So in that case, we use the isosceles triangle theorem, and we also, to prove that the triangles were congruent, we would use angle, angle, side. All right, I'm going to finish 11 and 12 on the next video. I'm going to have 2 videos posted, and then I'm going to do a proof on that one as well for those of you taking the weighted version of the test. So let's put an end to this one and start new on the next one.